Have you ever looked up at the night sky, past the streetlights and the glowing clouds, and felt a sudden, dizzying sense of scale? You are looking at billions of stars, and for a long time humanity stared into that vast, sparkling dark and asked one deeply haunting question. Is there another Earth out there? An Earth 2.0? A planet with blue oceans, white clouds, and maybe, just maybe, someone looking back? Let's start at the beginning. For centuries, the idea of other worlds was pure science fiction. It was the realm of space operas, little green men, and wild conspiracy theories about alien civilizations hiding just out of sight. We assumed there must be other planets like ours, simply because the universe is so mind-bogglingly huge. But until very recently in human history, we had absolutely zero proof. Then, our telescopes got better. We started looking closer, and suddenly the universe was teeming with planets. But did we actually find a planet exactly like Earth? The short answer is no. But the long answer? That is a thrilling mystery that forces us to redefine what a habitable world even means. Here's the deal. Finding a planet outside our solar system, an exoplanet, is incredibly difficult. Planets do not produce their own light, they only reflect it. Trying to see an Earth-sized planet orbiting a distant star is like standing in New York, trying to spot a single firefly buzzing around a blaring searchlight in Los Angeles. So, scientists had to get clever. They started looking for the shadow. This is known as the transit method. Imagine someone walking directly in front of a bright flashlight. For a split second, the light dims just a tiny bit. That is exactly what space telescopes do. They stare unblinking at thousands of stars, waiting for a microscopic dip in brightness. If a star dims at regular intervals, you have found a planet. When space telescopes started using this trick, it blew the doors off modern astronomy. We found gas giants and planets raining molten glass, but we wanted the Holy Grail, a rocky planet in the Goldilocks Zone. That is the sweet spot around a star where it is not too hot for water to boil and not too cold to freeze solid. This brings us to the planets that make headlines, the ones branded as Earth-like. But when you peel back the PR spin, so we've got layers of weirdness here. Take Kepler 452b. When discovered, the media dubbed it Earth's older cousin. It is rocky. It sits firmly in its star's Goldilocks zone. It sounds perfect, right? Like you could pack your bags and build a log cabin in the alien woods. Not quite. Kepler 452b orbits a star that is much older than our Sun. As stars age, they get hotter. If Kepler 452b ever had oceans, that aging sun is likely boiling them away right now, creating a runaway greenhouse effect. Instead of Earth 2.0, it might be Venus 2.0, a suffocating hellscape of toxic clouds. Then there is the TRAPPIST-1 system, a discovery that truly sounds like science fiction. Just 40 light-years away, we found 7 rocky planets crammed around an ultra-cool red dwarf star. 3 sit perfectly in the habitable zone. But here is the catch. Red dwarf stars are incredibly dim. For those planets to be warm enough for water, they must huddle up incredibly close to their star. When you get that close to a star's intense gravity, you become tidally locked. Tidal locking means the planet no longer rotates freely. One side always faces the star, trapped in eternal, blistering daylight. The other side faces the deep freeze of space, locked in an endless night. If life exists there, it would have to survive in a narrow twilight strip along the equator, a perpetual sunset ring where the ice meets the fire. We call these eyeball planets because from space they would literally look like giant, staring eyeballs. Suddenly, the idea of an advanced alien civilization waving at us from a green pasture feels a lot less likely. We aren't finding Earths. We are finding bizarre, extreme, funhouse mirrors of Earth. The universe is throwing strange curveballs. To truly understand why finding an exact twin of Earth is so agonizingly difficult, we have to zoom out and look at the macro scale. Our Milky Way galaxy alone holds hundreds of billions of stars. Statistically, there should be billions of rocky planets in habitable zones. It is the ultimate numbers game. This vast scale is exactly what fuels those fringe theories. The belief that governments are hiding crash saucers. or that hyper-advanced civilizations are watching us right now, like animals in a cosmic zoo. But grounded science forces us to look at the incredibly delicate recipe that made our specific Earth. It is not just about being a rock at the right distance from a star. Our Earth has a massive moon that stabilizes our planetary wobble, giving us reliable seasons. We have a churning, molten iron core that generates a powerful magnetic field. Think of this field as a giant, invisible planetary shield. Without it, highly radioactive solar winds would have stripped our atmosphere away billions of years ago. We also have a giant bodyguard named Jupiter. Its massive gravity sweeps up loose comets and asteroids, taking the heavy hits so we do not constantly suffer extinction-level impacts. When an exoplanet is excitedly called Earth-like, it generally just means its size and temperature might allow for a puddle. We know absolutely nothing about its magnetic shields, its plate tectonics, or its planetary bodyguards. So, what is the most logical conclusion to our cosmic mystery? Did we find a planet exactly like our Earth? No, we have not found Earth 2.0. But the reality of what we are doing is arguably much more mind-blowing. We have discovered that the universe is infinitely more creative than our narrow human definitions of a habitable world. Today, cutting-edge space telescopes are out there, peering directly into the atmospheres of these distant worlds. They are not just looking for shadows anymore. They are sniffing the air of alien planets for biosignatures like methane and carbon dioxide. We are exploring Hycean worlds, planets completely covered in global oceans with thick, hydrogen-rich atmospheres. Life might not need continents and a simple 24-hour day to thrive. Our Earth is a highly specific, spectacularly lucky combination of ancient cosmic accidents. Finding an exact twin is incredibly unlikely, but finding life? That is entirely still on the table. As we continue to stare into the dark, scanning the light of 100 billion stars, we are reminded of just how precious and fragile our little blue marble really is. We are floating in a bizarre, chaotic, and unimaginably vast ocean, and we have only just begun to dip our toes in the uncharted water. Every single new planet we discover teaches us something fundamentally new about the wild mechanics of the universe and our unique place within its grand, ancient timeline. The search for our reflection in the cosmos continues. Stay curious, keep looking up, and stay tuned.